Hey guys, Mr. Dealist, and we're going to start talking about graphing motion. So let's get right to it. So when we are graphing, we're going to use position on the y-axis and time on the x-axis, which can be a little bit confusing depending on how you're labeling things. And so we'll be a little bit careful about that. But basically, we have position here. I'm going to use the letter D for position for the moment. And we'll have a T here for time. So as we progress to the right, time is increasing. Of course, we can't go to the left because that would be going backwards in time, and that's just not going to happen. You could have an X for position if it represents a horizontal position, but that can be confusing for some people because this is the X-axis. So you can use whatever you want, but just be clear and consistent. So there are some basic rules. Time is always going to be on the x-axis. So as we are going left to right, we are going to be increasing with time. The slope of any line that you have on here will be your velocity. So let's say that I represent something like that. That's probably about the best I can do at the moment. So let's just kind of put a couple hash marks, and let's just say that that's the 3 meter mark, 4 meter, 5 meter, and so on. And then I'll put some timestamps, 1, 2, 3, and 4 seconds. So here we have the 3 meter mark. Well, at time 0, the object is at the 3 meter mark. After 1 second, it's at the 3 meter mark. After 2 seconds, and after 3 seconds, and so on, it's still at the 3 meter mark, and so it's not moving. In fact, it is specifically at the 3 meter mark the entire time. Also, keep in mind that this can also extend down into the negatives. So an object could, for example, do something like that. Well, let's think about this. The slope is the velocity, and this is a negative slope. And in fact, specifically, it goes down, let's see, it starts at the 4, it goes down 4 and over 2. So 4 over 2. All right, so the slope is going to be 4 meters divided by the 2 seconds. That gives us 2 meters per second, and specifically it's actually negative, isn't it? Because it's moving in a negative direction. So it's a negative 4 meter change, and we're looking at a velocity of negative 2 meters per second. So the slope of this line gives you the velocity. This is, of course, when we're looking at a position versus time graph. Let's look at this one here. We have a change in position, right? So here's our line. It goes up 20 centimeters in over 0.1 seconds. So the slope here, let's see, rise over run, we're looking at 20 centimeters over the 0.1 seconds. Our units are centimeters per second. 200 divided by 0.1 would be, 20 divided by 0.1 would be 200. And again, our units just transfer right over. It is going to stay centimeters per second. Moving in a positive direction, it is consistent because it's a straight line that doesn't change. Let's look at each of these examples. So here I have a red car. This line here that I'm going to be looking at time 0, it is at position 0. So as time progresses, it is moving more and more into a positive position, and it's doing that consistently. It is a straight line. So it goes from the 0 to the 5 meter mark, and it does it in 1 second. So it goes up 5 over 1. That would be a 5 meter per 1 second change. Up 5 over 1, it's still making a 5 meter per 1 second change. So the car's velocity is 5 meters per second. Let's look at the yellow car. So this is changing. It's a curved line. So let's take a look at what's happening. It goes up about 2 or 3, and then it goes over 1 second. So it's about 2 meters per second. But let's look at this segment though. This is going from the 16 up to about the 32 or so. And so we're looking at about a 15, 16 meter change in a time span of 1 second. So it goes from 2 meters per second to about 16 meters per second. It is accelerating. It's increasing its velocity, and it's also increasing that velocity in a positive direction specifically. The green car is at the 15 meter mark, and it stays at the 15 meter mark. It is stationary, not moving. The orange car is moving in a negative direction. It is constant velocity. Specifically, it is going down 30 and over 3. So that's a negative 30 meter change in a time of 3 seconds. Meters per second will be our units because I'm assuming that this is meters. And so that's going to give us a negative 10 meters per second. All right, so that's those 3 examples. I'll tell you what, I'm going to throw one more in here. What if I had something that looked like this? What would it be doing if it looked like that? Well, at time 0, this object was moving very, very fast in a positive direction, and it was the slope of the line. What's the slope of the line doing? It is kind of mellowing out. It is slowing down. It's getting closer and closer to 0, and it is going to come to a stop. And right about here at the 30 meter mark, it comes to a stop. Let's look at this. From segment A to B, it is moving in a positive direction with a constant velocity. It goes up 1, 2, 3, 4 in a matter of 2 seconds. So it's moving 2 meters per second during that time. Again, assuming that this is meters and this is seconds here. So it's moving at 2 meters per second, comes to a stop at the 4 meter mark, and it stays there for what, 1, 2, 3 seconds. Then it turns around, it goes in a negative direction, and it does it fairly quickly. It goes from the 4 to the negative, so it goes -9, it looks like. And it does it in only 2 seconds. It's going very quickly. It's going about 4.5 meters per second, negative, in the negative direction. So it about faces, and in fact, what's happening right here? Right there, it is crossing the 0 position. It's not changing its speed or velocity, anything like that. It's just simply crossing that line. It's crossing that line. It's just a spot in the room that maybe the person's crossing back over. Then what's happening right here? The person is about facing and immediately changing direction, but they're not going so fast, right? They're moving fast in a negative direction. They then immediately change direction and are now going in a positive direction, the same direction they were moving here, but they're doing it slowly. So they're going, let's see, 5 meters in a time of 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so we're looking at, excuse me, about half a meter per second, give or take. And so that's each segment here. So these are positive velocities. This is a negative velocity, meaning that it's going in the opposite direction, and this is a velocity of 0. Okay, just trying to get some practice to look at these examples. All right, let's move on to this here, where we have 3 graphs stacked on top of each other. We're looking at position, velocity, and acceleration. So up to this point, we've been looking at only velocity graphs, but I'd like to extend that further. So let's make something that looks something like, let's be pretty straightforward about it. In fact, you know what? Let's be super straightforward and simple. I'm just going to make a horizontal line. Something looks something like that. I could probably do better. Let's do it. Let's make it better. Let's actually make a. There we go. There we go. Looks great. So it's at the 3 meter mark, and it is going to continue to be at that 3 meter mark. So what is its velocity? Its velocity is 0. And so this should be right at the 0. I freehanded that, and it looked pretty decent. So this has a slope of 0, so this will have a velocity of 0. How much is the velocity changing? It's not changing at all, so its acceleration will be 0, right? All right, so there's those. Let's look at something else. What if I've got a velocity? Okay, this time I am actually going to have a velocity. Let's go something like this, a very gradual velocity. Tried to make it so that way, it does decently. I'm trying to make it so that way by the time it gets to 10 seconds, it's gone up 2 meters. All right, so by the time it goes 5 seconds, it is at the 1 meter. So this is 1/5 right? This is 1 divided by 5. It is 1/5 of a meter per second. So let's just kind of make these units. Let's see, 1, 2, 3, 4. Let's put one more hash mark up here. Let's make that 1 meter per second. So that means that 1/5 of the way up there, it would be at a constant velocity the entire time. It is at 1/5 of a meter per second the entire time. It should be a nice straight line. It's horizontal. If this is a straight line, this is a horizontal line. Because this thing is moving at 1/5 of a meter per second the entire time, this will be at the 1/5, right? That right there will be 1/5 of a meter per second. And so this entire time it's moving at that rate. It should be above the x-axis. And if we had some, you know, I'll give that example in a minute. And the acceleration, what's the acceleration here? It again will be at the 0. As long as this is a horizontal line, that will be at the 0. What if we had something that was moving in the opposite direction? Just make a line like that. I'm not too concerned about the slope right now, but it does go down 4 and over 5 or 6. So, you know, we're fairly close to 1 meter per second. And in fact, you know what? Maybe I'll just make things simple and try and do that. Okay, so that's about 1 meter per second, negative 1 meter per second. And so let's see. 1, 2, 3, 4. We said that these were fifths, so this is coordinating with the velocity graph. So this thing is moving at a negative 1 meter per second. Remember, this is 1/5, 2/5, 3/5, 4/5, 5/5. That's negative 1 meter per second. That's the velocity. It is relative to this one here. Okay, and then what about the acceleration? Again, it's a straight line. It has an acceleration of 0. It has an acceleration of 0. Is it always going to be an acceleration of 0? No. So let's erase all this stuff. Let's kind of start from scratch to some degree and look to see what happens. Whoops. Let's look to see what happens when we have something that does not have an acceleration of 0. What would that look like? Okay, how about something like this? Okay, so in this case we have something that starts at a negative position and accelerates. It's starting off with the velocity of 0. Wait, look at that. It's a horizontal line right there, isn't it? So it starts off with the velocity of 0. And then what you can do is, look right here. From here to there, what's its velocity look like? It goes up and over. Let's just assume that each one of these is 1. Okay, forget the whole thing about 1/5. Each one of these is 1. So from here to here goes up. It goes up almost 1 for going over 1. So we're looking at between this segment and here. It should be a slope. It should be at the 1 position somewhere, right about there. It should be at about the 1 position. I'm gonna get rid of that little stray mark. So right there it's about the 1. And then what about here? From here to here, right? I'm lining it up. How much does it go up? It goes up, let's see, it goes up about 1, 2. It goes up about 2. So right somewhere around here it should be at the 2. And then look how much it goes up there. And it seems to, between here and here, it seems to like almost go up in an infinite amount. Although that's not going to be quite right, but in fact, if you notice here, let me forget about this one because it gets a little bit squirrely there. But look, you notice that actually looks like it should make a straight line, and that's actually what it should look like. So an exponential line here will make a straight line here. In fact, it probably won't really continue along that same path for too much longer, but you get the idea. So a exponential line here gives you a straight line here, but with a positive slope. And whatever the slope is here, let's see, it's looks like it's about 1/2. So this should go right on the 1/2. Right? That's meant to be at the 1/2. Maybe I can raise it up just a little bit. There we go. And so whatever the slope of this is will be the value here. Okay, so there's an example of an exponential increase and how position, velocity, and acceleration are all interrelated. Okay, so that's a little bit of graphing, and you just have to like really look at each little segment, look at the slope, and whatever the slope is there, that's where you put the value on the next graph of position, then velocity, then acceleration. Typically, we'll deal with things that have either zero acceleration when we do these graphs, but on occasion, perhaps we'll take a quick little peek at it. Okay, so there's graphing. Really, this is the one to focus on here, position versus time graphs. We should really try and get used to looking at these and take some time and practice looking through those examples. So things like this, look at those examples, think about what's happening. Okay, all right, well, let's see if I can do one last example. What if I had an object that was falling? I had an object and I just dropped it. What would that look like? So I think that the way that we'll look at it, let me see if I can get rid of some of this stuff. Almost there, right there. Okay, so I'm going to assume that this object is starting in a positive position, and it's also at rest. So it's in a positive position, and then I drop it, and it's going to pick up speed. So at first, it's not really moving very fast at all, so it should be horizontal to start. And then at some point, it's going to start picking up speed, but in a negative direction. So the slope should be increasing, but increasing negatively. And the velocity of this object was, well, the slope here was 0. So it starts off at a velocity of 0. And then over here, it's got a large velocity, but a negative velocity. So it's going to be something like that. And then the acceleration, something like that, right? It's going to be below the x-axis because it's a negative acceleration. Gravity's pulling it down in a negative direction, causing it to move faster and faster in that negative direction. And that's going to be what gravity's going to do. Okay? All right, so that's graphing in a nutshell, and hopefully that's helpful. You guys have a good one.